Okay, you should see Paul is recording.
Yep.
Yeah.
Okay, insert witty comment.
What?
Great.
Hold on.
Sorry, that's for my pre-start thing. Anyway, shall we go? And in 5. Hello, everybody, and welcome to another E5 podcast. And there's some familiar faces, so let's introduce ourselves.
Oh, hey, David, SparkyNinja here.
Hello, I'm JW.
And we have with us a returning guest, and it feels like weeks since we've spoken to him. Introduce yourself, sir.
I'm Sean Passant, the technical manager of Dehn UK.
So for those listening, you'll be familiar with Sean. He's Dehn UK and also the vice chair of Atlas, the lightning protection industry body. So
Yep.
Welcome back. We had so much to talk about in those last 2 that we did with you. We thought we'd get you back in to talk about some more of the thoughts, concerns, questions that we have around lightning protection and how it integrates with the low voltage electrical systems, and how we as electricians and electrical engineers, designers, selectors can make sense or try to make sense of this complex subject that's always been the dark art. It's like go to Hogwarts to learn this sort of stuff. First thing I want to ask you about now, in the DPC which came out, Dave, when was it? Was it July 2017 or something like that?
Then, yeah, 17.
Yeah, so around that time, I think it was July or August, the DPC for the 18th edition came out, over 884 pages, if I remember rightly, and it introduced this whole local foundation or earth electrode, which I think it's fair to say kicked off the biggest stink ever. Nobody really complained too much about SPDs because I think it's fair to say nobody really knew what they were unless they were industrial guys. And arc fault detection was more of what, how does it work? And I remember, and this is true, I remember going to the CEF Lives and the ECA live events where the industry guys would be talking, and you go up to them and go, so come on, give me the fundamental principle. And they were still learning.
Yeah.
This was an emerging development and understanding and learning of this technology. Now, foundation earth electrodes, that was one that people were going, yeah, I can do that, because that was Sparks going, right, I'm going to hit a copper rod into the ground. And then it started the questioning of, well, how do I do that if I'm in a masonette, top floor flat?
Yeah.
But I have an EV charger which is fed off my board downstairs to where my car's parked, etc. And it's opened up a huge can of worms. I want to get your view, because Dehn UK do lightning protection, surge protection, and earthing specialists. So could you maybe give us your download on what foundation electrodes is to you, and what you see are the positives and the negatives maybe?
Okay, so coming from a German company, foundation earth electrodes are the norm, in fact, in most parts of mainland Europe. That's just how they do earthing, and they look at us in a slightly weird way that we're still knocking rods in. Most large commercial buildings in most of our big cities have been using piles, rafts, foundations, secant piling, those kind of things for years and years as their earth. I think it's inevitable that it's going to happen. I think it's a safer way to get over all of the issues of floating neutrals and PEM faults and stuff like that. So from our point of view, we welcome it. We think it's maybe overdue. And as an organisation, we have some kind of real specialism and knowledge in that department. Particularly, we have a chap called Joseph Burkle, one of our product managers over in Germany, and that's his particular pet subject. And I know he's already been over to speak to a couple of standards committees in the UK about that subject, to give them the experience that the Germans have had since about 1960 when they started doing it.
Is there any reason why the application of foundation earth electrodes makes more sense in Germany, but over here is more of a challenge, more of an obstacle, more of an adjustment, that we don't naturally adopt it, or we did kind of oppose it initially?
I would say, domestically speaking, we don't build necessarily a reinforced foundation, and certainly not a cellar or a basement area. In Germany, they do, and they would, and in fact, in majority of countries in Europe, they tend to go for some kind of cellar or basement, which is where they have their kind of storage and their utility spaces and things like that. So it makes it slightly easier for them. They have a reinforced structure, which they then supplement with a conductor they run around in that reinforced frame that then all gets cast in, and they would have equipotential bonding points that are again cast in, so that anyone else coming along afterwards can then extend off of those, and they know that they are connecting onto exactly the same earth as everybody else is doing.
It does make sense. I mean, my cousin lives in Canada, and her living room is in her basement. In North America, everybody seems to love their basements. Their basements aren't just an area that's murky. A lot of them, it's a real living area. And my cousin, her house in the basement, it's basically a load of steel, inverted underground. I suppose it's more space, bigger homes. It's better options for the people. But in the DPC, there was a new regulation 5421-201. So it was a UK specific regulation that was proposed, and it required a supplementary earth electrode at the origin of the installation to supplement the existing earth. But I'm pretty sure in the 18th edition, isn't that defined as now a PNB earthing system? Or am I going completely bonkers here? But I'm pretty sure in part 3, it's actually defined, that is shown in the diagrams as a PNB earthing system, protective neutral bond, because you're connecting it at the origin. Where the neutral and the earth separate. So it was defined as a PNB, which is another thing to confuse electricians. But then there was another note underneath it that strongly recommended provision of foundation earthing for new builds.
Yeah, and my understanding is as well that they're looking for a foundation earth rather than a rod or a nest of rods being put in, and that I think comes down to the risks associated with driving rods and striking underground surfaces, which you don't get quite so much when you're putting it into a foundation because you've already dug things up, and also the accessibility to that later on, whether because people are deliberately trying to damage it or whether it's just a bit of kind of horseplay and mischief. But if you've got a conductor that is fundamentally kind of cast into that ground around it, it's perfectly safe. No one can get to it, and you can use relatively cost-effective equipment as well, because we're still very much using copper in this country for all of our earthing requirements. But again, mainland Europe would look at us slightly strangely. In Germany, they use copper for one thing, and that's brewing beer. They certainly wouldn't entertain putting copper in the ground. Everything they do is done with steel, whether it's galv or stainless. They would do that, and certainly galv is much cheaper than copper would be.
I was going to say, actually, because I mean, we put some just on a side note, we put some temporary rods in for construction site supplies. This was at Stratford around 2010, before the Olympics. It was all part of the Olympic works. And I remember when, I think we were on site for about 2.5 years. We were building a new London Underground platform and an extension to the existing Stratford station. It was an annex. And those electrodes were in there for about 2.5 years. And when we came to remove site and take it all up, the electrodes had pretty much disappeared. Okay. They were gone. They just corroded. They turned into powder. And it was quite confusing for a lot of people. And then we spoke to this earthing guru, Dr. Roger White, who then turned around and said, well, you've got 2 different types of DC traction system, 2 different types of 25 kV system. You've got massive stray currents floating through this wonderful bit of copper, and DC does like to jump on and off of bits of copper under the ground, and henceforth it will cause it to corrode. And he says, what do you expect putting that in the ground? And we were like, oh, okay. And it turned out that they had to do a specialist design for the bridge structure and all of the rebar, and somehow do something special to that to insulate it. And that massive steel bridge that crosses over Stratford, that literally is floating. It's his own earthing.
Yeah, that will probably have a cathodic protection system that might involve isolated spark gaps to keep it separate from other systems. That's again not unusual to Dehn. That's something that we provide equipment for. Another one of the weird and wonderful products we have in our range. We provide that to CP contractors all around the world, protecting pipelines and reinforced structures. So corrosion is a big issue. And yeah, you're right. In certain circumstances, copper can corrode pretty quickly. And if you've got a lot of mineral salts in the ground, a lot of moisture in the ground, as I imagine you'd probably have in Stratford, I guess there's a bit of water around there, then that can certainly lead to enhanced corrosion. So that could be a problem.
So when we come full circle and we go back to looking at foundation earth electrodes, do you think maybe steel would be a commonly discussed better alternative for corrosion protection?
I think so. I think certainly galv is likely to be a favoured material, and I think that supplementing the existing reinforcing is something that will probably happen as well. And so I know some tests have already been done, and I know that they're achieving some pretty low readings. Certainly lower than your average kind of rod knocked in for a TT earth. So I think it's, and we know with the issue of islanding and people becoming prosumers and things like that, having a reliable local earth is going to become really quite important. So I imagine foundation earthing is going to be something that we all end up living with. And I think there's already certainly M&E contractors that are aware of it and are thinking about it, and certainly we're thinking about it, and we even know some house builders who are starting to think about it and starting to think, actually, maybe this is something we need to consider as well.
Yeah, it's going to be interesting to see how house builders consider it. Generally, they just build a trench, put a layer of concrete, and then just put some bricks and mortar up to a height, and then put a damp-proof concourse and backfill it with mud. So it's going to be interesting. I mean, for the industrial electrician, I have, in all the years I've done heavy industrial when I was doing contracting or delivering works, generally the designs can be quite terribly poor. And I remember we had to put in a substation for Crossrail. And it was the Westbourne Park area, and luckily we had to put in 280 piles that were 1.8 meters wide and 24 meters deep, with a pile cap. And the substation which sat on top of it, I put 2 earthing conductors to the pile cap, and we connected them in with a nice little earth hatch and labels and all that, indelible labels. And when we tested it, our meter could barely read anything. It was like the world's greatest electrode, but that needed maintaining. On the domestic front, there is always going to be, and I'm sure Dave and John, you can see it. Well, this is all good and dandy, introducing the concept and the premise of additional local electrode, but we now know we've got the hazard of, we've got buried surfaces. We also know we have the hazards of, if we put an electrode in, it could pick up current from a damaged pen conductor. So we could be introducing currents into our system. I have the view of the domestic of, just do one big grid when you're doing your driveway, which I'll be doing like my old man did when I was a kid. It's the implementation in the domestic. If we're going to do this and get the hearts and minds of electricians, the domestic sector is king, and we need to find a way of giving them an easy way of understanding of this needs to be done or this could be done.
Yeah.
I mean, that's perfectly workable for a new build or for maybe some new driveways, maybe. But again, with 722, one of the key things it said under TN systems, right at the end of the protection strategies, it says you don't really want to go to a DIY TT because we don't really want to bury an electrode in the ground near buried PME. And then if this comes full circle, the argument could come for this as well, unless they deliberately find maybe putting. I mean, technically, there's no reason why the electrode for the foundation couldn't be on the opposite corner of the building. So there's no reason, but that's the thing that they'll have to determine, because it might be that for a while you'll have a little bit of distancing with the idea of us upgrading existing systems for this. New builds will be fine. I can anticipate that, but to upgrade an existing building, there will be a little bit of a.
Okay, Dave. I'm in Hampstead. Let's do a bit of a role play here.
Okay.
So I'm in Hampstead. I have been called out to a 4-story townhouse. There's a family with kids and all the rest of it. They live in, let's say it's a split townhouse where there's 2 families on 2 floors. So they're well spaced out. But they're having a joint rewire because the wiring is 70, 80 years old. Excuse me. And the work has to be to 18th edition amendment 2, and let's say in Amendment 2 we introduce foundation electrode, that electrician's going to look at that and just go, bang an earth rod in.
Yeah, well, the first thing I would say is, what would Amendment 2 say about that? Now, I can't see it using the word shall. I think, it would be recommended or could be considered. They won't use shall immediately because that's going to create a shitty mess.
I think what they'll end up saying is consideration should be given or shall be given. So you shall consider the application of some sort of connection of the fixed electrical installation to any existing foundations. If there isn't any,
similarly,
there needs to be a note that says within built up residential areas, we accept buildings were not built with this form of fabric under the ground.
And similarly, whilst I can see that this is a great idea to think about considerations of broken PME systems or floating neutrals, etc., that's not going to be a very popular reason to introduce a regulation, because it's going to obviously be saying a lot about DNO supplies. On the other hand, if we wait until prosumer becomes much more of a understood driver direction for the industry, and they've put that work in to actually, promote the idea of prosumer installations, then eureka, it's a good idea to put an earth electrode in for foundation with those as well. So they'll probably try to swing the reason or the intent to support prosumers going in island mode than actually thinking about breaking down of PME systems. So, the politics will probably get involved with how that's applied. So it'll be shall for a couple of editions, I anticipate.
Do you think that the electrician then will have to, as part of his works, document his considerations? So literally write some sort of noted memo that he issues as part of the certificate that says, listen, I'm in a 4-story townhouse in Hemel Hempstead. It's a built-up area. It's assumed there are at least 2 gas mains coming to this property. It's a very narrow garden. There's no driveway. There's BT. There's residential services. There's DNOs. I'm not taking the risk of doing it. Plus, the customer doesn't want an earth rod or a load of earth farms or a big black conduit on their walls, etc., etc. Now, it's not down to the consumer to an extent, because it's up to us to give them competent advice and advise accordingly on how the fixed installation should be compliant. But on something that involves engineering judgment, unless we give correct consideration and guidance, it then easily innovates into the wives' tale. And then it just becomes, whatever. Yeah, my mates down the pub, Danny Wholesaler said you don't have to do it because you just get them to sign a little widget and you're covered. Like with arc fault and surge protection.
Oh, it's the same
sign. You don't want it now. Where you go, whoa.
Yeah, it's kind of the same right now. The situation we have with AC and Type A RCDs. We know that there's a direction of improvement, but do we jump on it if we've not been told to go that way yet in the regulations? Because AC RCDs are still considered suitable for general use.
Well, they are right here anyway.
They're pretty much, yeah. And so you got that point. You got that point where the regulations are not yet driving you to do that.
Have we done a podcast yet where what we need to do? We need to invite the head of BEMA or whoever writes the RCD guidance to come on this podcast, open invite, and tell us why AC RCDs are not yet banned for use when they are in other British.
I want to know which culprit said the wording of AC RCDs are suitable for general use without helping us understand what the hell that word means.
Yeah.
What does general use mean?
Well, they're not going to tell you what general means, because if they did, then it would reveal to everybody that they're not suitable for any use and they should have been banned 30 years ago.
That's being John. You're being a bit general there, mate. Do you mind?
Mind? So the people who put that in, I want them to tell me why. I know why, but I'd like them to say it, because they bloody well should do if they're in that position, because it's just stupid.
The biggest problem. Sorry, John. After you.
Yeah, I'll just say with the foundation electrodes again, the way they had it in that draft thing would have been a complete disaster, because it would have had people going out and literally just banging in earth rods all over the place for no particular reason. Yeah. And if you've got an existing installation, sticking in a 4-foot rod in the ground is not really going to achieve a whole lot anyway, especially if people are just going to shove it randomly in the front garden or something. So that's probably why it was removed from that.
I think I agree. I think electricians need to go on a bit more of a learning journey with regards to the idea of prosumer installations as well, before we start throwing this electrode in the garden for no apparent reason.
Okay, so let me play devil's advocate here. Let's take a step back in time. 15, 20 years ago, as electricians, we were told, if in doubt, rod it out. Bang a rod in, job's a good one. Get your impedances down, your breakers will disconnect.
Yeah,
Let's
but we've
now
just spent 15 years of saying you don't need those RCDs.
Hang on. I'm on. Let me flow. Let me flow with this, okay? So, those rods suffered. I know. Let's stick an RCD in it. 1,667 ohms. Job done. Now we're in the realms of, well, them RCDs are for general use, and really the connected loads. There's a bit of an interaction issue between the two now. They may not work. And now we're of the view of, well, the DNO don't really maintain their network, and this is my personal view, because I used to work for a DNO. They are so poor in maintaining and understanding the network, they are transferring the liability for their damaged pen conductors or worn and corroded pen conductors onto end users and the installers and contractors. Now, PME cables, they only came out in the 70s because they're a money-saving idea. But how much money have they saved them over the last 30, 40 years, and how much is it going to cost our industry? It's going to cost us masses because we decided to go cheap in the 70s to doing all of this PME. So now we have fixed installations which leak AC. They leak DC. Yeah, and now we're putting in electrodes, or we're suggesting electrodes, but you put DC into a foundation electrode, it will jump on and off and corrode your electrode. It's becoming the interaction between earthing, fixed installations, RCDs, and end products are becoming this web of complexity that we need to really start being able to come up with some very simple ways of thinking when we're approaching an electrical installation. And the wiring regulations demonstrate how unfit for purpose they are when they use the word general just on the RCD term. And that's what scares the hell out of me.
Yeah, I mean, the key thing maybe to be considering isolating the DC equipment from the AC and from Earth altogether. You know, like the idea we've had in our look at the future idea, you know, where we can generate and we can have, you know, we can store DC. Isolation, separation from that earthing might be the most suitable protective function.
But for me,
years away.
It's exciting times, but I think what worries me as well is chapter 33 is compatibility. Okay, now that is half a page. There's 3 regulations in that, and talk
about each of those regulations for a day.
That regulation, you could do a 1-day course on that half a page, trying to get people to consider and understand. And it's like it just says in it says, so we, you know, what does it say? These characteristics include transient overvoltage, undervoltage, unbalanced loads, rapidly fluctuating loads, starting currents, harmonics, earth leakage, excessive protective earth conductor current not due to a fault, DC feedback, high frequency oscillations, necessity for additional connections to earth, power factor. There is so much in that. It's mind-blowing.
There's a lot there.
There's tons.
And then again, remember, as we said in the previous podcast, electricians just fly past that because it's only 2 questions in their exam.
But this is the key. This is the key to correct section erection is at least coming up with a framework of understanding in your head. It may not be perfectly right. None of us are 100% dialed in to this wonderful world of electricity because the technology is becoming more micro, compact, electronic driven with an end goal, but also whatever positives there will be a negative impact on the power supplies that it's using. Harmonics. Look, you speak to Paul Skirm, my God. We're going to do a podcast with Paul Skirm on harmonics, and that's just going to be one where I'm just going to sit looking like this going, huh? What? 5th what? 3rd what? 12th what? There is so much we don't know, and it's where do we draw the line as electrical contractors and installers when trying our best to do the reasonably practicable when selecting and erecting, and that's the difficult thing. And I think the industry isn't helping when they're dumbing down and using stupid terms like general. So yeah, I think it's fair to say there is going to be in Amendment 2 or Amendment 3, depending on how they want to play it. This is going to be coming back in anger.
Yes, well, I mean,
it's going to be coming back.
The public draft was 801 pages, by the looks of it. A lot of it was taken out. 18th edition should have been the 18th edition. When you actually look at the Amendment 3 of the 17th and you look at the 18th, there's nothing really there that substantially warrants a new edition. They just took it all out when Part 8 was basically shelved. So it's going to come in, and it's going to. I mean, my concern from a training perspective is how the industry is going to carry on doing 3-day courses, 2.5-day training, or preparing to do an exam, and then half a day exam. Yeah, well, that's the point. It's not going to change, which is why I'm starting to look at creating qualifications with others to try to oppose this, because it's got to. I did an online 18th edition course lately, and I ended up going on to the 5th day, and I've actually got my software tells me that the guys have been on that course for over 39 hours on an online one-to-one course with me, and that's because we actually didn't rush it and we took the time to cover it, and that's without any preparation for assessment, and that's just chewing on the information that's in there now. When the part 8 comes in and prosumer comes in and energy efficiency comes in, you're adding, I've said this in my little community, so you're going to look at least at maybe 55 guided learning hours for that course.
Yeah, I agree.
And so they're either going to have to split it into 2 different things, or they're going to have to then rewrite the qualification, which they won't, because they make a lot of money on it right now.
Well, speaking of splitting into 2 things, BS7671 Part 1 and BS7671 Part 2, and how many other parts? So, yes.
That was my idea. Yes, that was my idea. So, Sean, I don't know if you heard, but I had an idea that we basically take chapters 1 to 6, so fundamental principles to inspection and testing, or verification as it's going to be called.
Yeah.
And we make that BS7671 Part 1. That's the installers, what you need to know. That enables us to maybe put some more detail into those sections, which would be good. And then Part 7, special locations and design considerations, becomes 7671 Part 2, which also allows us to create more information for the installer. So effectively you have 2 Bibles that you can pick up, and one you could say is a level 3, one could be a level 4, but you could encourage and stimulate with the volume of stuff we're expected to learn, that you could shift the journey of learning to you're going from 2, you're going to 3, you're expected to go to 4 to be a minimum competency. And I'm sure the likes of Dave will be doing stuff. It'd be really interesting for when the Dehn Academy or your training center opens. It'd be really cool if you guys could run earthing courses for electricians to enable them to understand the intent and how to implement the earth electrodes, whatever form, because we haven't seen Amendment 2, obviously, so we don't know. But whatever form that's in, to be able to develop some content for electricians to be able to attain and understand, that would be really good.
Well, I think it's something that we will do when that, in fact, possibly even before that amendment comes out, because it's something that people are already starting to think about and already starting to talk about. From our point of view, we don't see it being an electrode. We see it being some kind of mesh or ring or use of foundation. So obviously, we're going to be looking fundamentally at possibly newer projects, new build, and those kind of things. But it's certainly something that we're very interested in pushing. And as I say, we've got the product range and the expertise back at headquarters in Neumarkt to do that, because we're coming off the back of 70 odd years experience of doing that in Central Europe.
Just be mindful. I went to Austria to meet Eaton and meet the German scientist there, and it was great because we had to redial our frequency into German and Austrian FM, and they had to dial themselves into UK Spark FM, and it was amazing how many common themes that we had, because we were talking and we were like, when the penny dropped, we were like, aha, now we understand there's a microprocessor, it's got programming and software that looks at the characteristics of this waveform. Get it? How do I explain that to a UK Spark when they've never thought like that? They've never been taught. We also have a skills shortage and a competency and behavioural shortage in the UK. And the German guy went, yes, we have the same in Germany. And I was like, hallelujah. It's like, yeah, some of our guys are terrible. And I was like, oh, wow. So it's an EU thing. There are, you only got to look at some of the Facebook groups where you can see bad electrical installations are not a UK specific. They are a global specific issue. And this is one of the fears I think a lot of people have had, where I think it's fair to say that we are introducing more safety devices to mitigate poor electrical installations. The trouble is, as we know, if somebody who is incompetent introduces a 10-way arc fault detection board and hasn't correctly selected and erected, they may become null and void. It's like when I speak to people and they go, oh, I'm going to get a 10-way arc fault detection board. And I go, but why? And they go, well, because it's super safe. And I'm like, but there's the energy you're going to use unnecessarily. It's not going to see an arc under 2.5 amps. So have you given any consideration to the installation? And you just get a glazed look. So I think there's more to be done. So yeah, I think it's fair to say Amendment 2 or 3 or whatever, this foundation electrode is going to be quite an exciting development. and how that is communicated to electricians. Should we move on? Next subject of debate.
Yeah, shall we go on to rolling spheres, shall we?
Yeah, absolutely. Probably my favourite subject, actually, in lightning protection. The rolling sphere is a methodology. There are three methods in 6305 for determining where conductors or lightning protection should be put. One is the mesh method, which is a really kind of dumb fix. You just basically divide your roof up into the corresponding mesh size for your level of lightning protection, and you apply that mesh to everything. There's the angle of protection, which is dependent on the height and the level of lightning protection. You read a table in the standard that tells you an angle that's applicable to your project, and you apply that angle of protection. But both those methods are limited in many respects, and the standard talks about that. They can only be used on plane surfaces, they can only be used on simple structures, etc. And they're also restricted to height. Once you get above a certain height, you can't use the angle protection method anymore. The rolling sphere is the most accurate method, and it's the method you can use for all types of buildings at all heights of buildings. And it is basically an imaginary ball that is replicating the final step that a downward step of lightning could take. So the final step of its journey, wherever it may go, that sphere represents that final potential step that it could take. And you roll it around a structure, and where it touches, you need to protect, and where it doesn't, you don't need to protect. And if you can stop the rolling sphere touching your structure, then you've achieved that protection. The biggest problem is that people struggle with the concept of an imaginary ball, and they also get the concept of how big the ball is completely wrong. So when I talk to a lot of people, even people within the lightning protection industry, about the rolling sphere, they talk about rolling a tennis ball around a shoebox. That's the analogy they give to try and get that message across to people. But that is completely out of scale, because the ball's massive and the building's much smaller. So you should really think about rolling a football around a matchbox. So for a level 4 system, the rolling sphere that's applicable is a 60-meter radius. That's 120 meter diameter and a 377 meter circumference. That's enormous. And you could be rolling that around a relatively small building. If you think about a relatively small industrial building, you could imagine that it's going to be, I don't know, tops, it's going to be maybe 50 meters long, kind of 40 meters wide. So the sphere is actually much bigger than the building is.
That sounds like a very unique or uniform number. I mean, where does that number come from of the scale of this sphere?
That's all driven by standard. So you have a 60-meter sphere, you then have a 45-meter sphere, a 30-meter sphere, and a 20-meter sphere based on that level of protection. I just need to quickly flick my computer on, by the way, because I've realised it's not plugged in.
Okie dokie. Because I've seen very often these illustrated with very, very, very large spheres for small buildings. Which sounds like the accurate way to illustrate it. But then I do see buildings with the sphere in like 20 different positions across the roof. Where really the sphere is actually probably the same size as the roof area. So it's not a huge sphere.
So I mean, for a level 1 system, you've still got a 20-meter radius ball that you're dealing with. That's still 125 meters in circumference. That's still a pretty big ball. When you think that for a level 1 building, it's usually a level 1 because it's got something explosive in or something like that. And explosive stores on the whole tend to be quite small. You could have a level 1 system on a really big hospital or something, which would be quite a large structure. But when you imagine that structure is then possibly terraced as it goes up, and it's got, you know, lift overrun rooms and motor housings and other bits and bats on plant rooms on the roof. Once you then start to manipulate that sphere around, it's not too difficult to put some measures of protection up to push that sphere away and stop it being able to touch the building. We use
that being upright.
Yeah, it could be. It could be continuing wires. It could be air rods. You can have lateral air rods as well. I think a lot of people don't realise that. So you can have an air rod that goes up, and then it has another section that comes out the side again to push that rolling sphere away. And we use the ground, obviously, as our earth reference plane, and we roll that ball up to the building so that it's touching the ground, and where it touches the building is where we need to start considering our protection. We use a 3D modelling system, so we use SolidWorks to be able to model that for customers. So we build a model of their building. We then replicate the rolling sphere going all the way around it. where it touches, it needs protection, and we then deploy our protection measures to stop the sphere touching. And then we're able to create a kind of a translucent layer that we show over the top of that building to prove to the customer that everything is under that layer, and that means everything under that layer is not exposed to full lightning energy. So it's an inherently safer way of doing things as well, because if you're parking your car in the car park and you're running into the building because there's a storm, you want to be under that protection as soon as possible. And if you've got an area of protection that's afforded over that volume of space because you've used the rolling sphere as your methodology, that distance away from the building starts to kind of increase, because using a 60-meter sphere, quite a lot of the ground at ground level is actually protected. So you have that area where the rolling sphere won't actually be touching any part of the building, and immediately around entrances and exits and things like that become safer spaces for people.
So, wow. So just a quick one then. If I'm an end user, I'm a client. So would I expect then my lightning protection risk assessor to produce that level of information for me? Would he be looking at a rolling sphere model to inform a better and more robust?
Most of the time, no, they don't. Most of the time, for a fairly normal building, they are going to default to probably the mesh method. The problem with the mesh method is if you just apply a mesh without any other thought, you're putting protection where you probably don't need it. And that gives me a couple of issues. One, it means that you are charging people more money. It costs more for that fat material, right? And more time to do it. But it's also, again, I come back to the same thing when I talked about in the last podcast, was this business of making men do working at height that they don't need to. And we know we should be reducing our exposure to working at height. And if you're just blindly putting a mesh over everything, and the mesh sizes, if we don't know about these, the mesh sizes for lightning protection for a level 4 system, it's a 20-meter mesh. For a level 3, it's 15. For a level 2, it's 10, and for level 1, it's 5. So a 5x5 mesh grid. That's an awful lot of conductor tape. Very labour intensive to install that on a roof. And if you're doing that, you're subjecting men to working at height that could have been avoided simply by using the rolling sphere and simply by erecting some air rods. And it's not too much to ask a professional contractor to have a package like Revit. You know, they don't have to have SolidWorks. We've got SolidWorks because it does other things for us. But a package like Revit makes it really quite easy for them to 3D model that and to be able to manipulate that sphere and show where that sphere may touch. If you try to do rolling sphere theory, by the way, in 2 dimensions, you will get it horribly wrong. And I've frequently seen people rather misguidedly having a plan of a roof, and then they draw circles on it, concentric circles all the way around, thinking that they're actually getting their rolling sphere correct. And of course, you know, a circle is different from a sphere for lots of reasons. It's a 3-dimensional shape.
I've actually seen that. I actually saw a lightning protection guy years ago getting a drawing and went, "There you go, drawing a circle." And I was like, "Oh right, oh okay."
Yeah.
Silly question then. When doing the rolling sphere modelling, do you just do it for the building in question, or do you take into account surrounding buildings?
That's a really good question, actually, Paul. So if the client owns and controls all those other buildings, then absolutely we do, yes. So if we were typically working on a water treatment work, for example, we just cheat and we use all of those tall structures. So the really big sludge tanks and things like that are going to provide protection for the smaller buildings and the MCC kiosks and the cake reception plants and all the other odd things you get in a water treatment work. We will use those tall structures, mount our air rods on it, and linking them together, you can create a network where some of the structures lower down have no protection on at all, but are fundamentally protected from lightning. So you haven't individually applied things to it. So that ends up giving you roofs that you never have to access at all. You use those tall structures, you use that big flue, you use those 2 big tanks, you use the tallest building you've got there, and by connecting those and looking at the whole site kind of holistically rather than individual buildings, and we know in the UK that would be tendered as individual buildings and people would only look at it as individual buildings. If you look at the whole site, then you can give someone a site-wide protection system, completely eliminate lightning energy from that site, so your staff are then safer when they're walking around doing their work, and you haven't accessed many of those buildings, and those buildings are protected without ever actually applying a single bit of conductor to them.
I was more thinking in kind of in London, where I am at the moment, like Fenchurch Street is one of my stations.
Yep.
And there's it's quite a complex labyrinth of various buildings that are layered, intermixed. and other stations like Waterloo. How would I go about applying the rolling sphere if I don't own those other buildings? But yet I see a benefit to applying that methodology to reduce my risk of working at height and further OPEX maintenance costs.
Yeah. So that would be done in two ways. Firstly, your risk assessment would take account of that, because you would have areas and elevations that the rolling sphere can never touch. So you would use, we have a thing called the CD factor, which is all to do with how exposed or isolated the structure is. And you would use a lower value because there are parts of your building that can't be touched. If you've got party walls, then that elevation can never, ever have any lightning energy because the rolling sphere can't touch it. If you then deploy a few air rods, quite simply, and once you then come to roll your rolling sphere over that site, again, if you've got areas that aren't being touched because it's resting on other structures, you're not going to be putting protection in other places. You shouldn't rely on other structures for your protection, but if the rolling sphere can never touch something, then it's never exposed to lightning energy. It doesn't need any further protection.
Okay.
And that's not being done in London.
What if your building went under somebody else's building, and there was some method where your network or your cabling or your infrastructure was potentially exposed if their building was not protected?
That's quite niche. I don't think the standard takes kind of account for that. The overriding factor with using rolling sphere is you only need protection where it touches. So fundamentally, if it can't touch that part of a structure, that part of the structure doesn't need protecting. And certain big city centres are areas where that should be exploited more than it currently is. It should be exploited more, and as I say, that would mean lower cost, and it would mean less working at height. And I'm all for that. You know, it's something I'm quite kind of heavily committed to, is reducing working at height, because we just do too much of it. There's no two ways about that.
Do you know what? I don't disagree at all. My concern, okay. Go and take a little step back here. The lightning protection risk assessment. Where is the start and stop point? Because, okay, let's say, for instance, I go out tomorrow and I say, right, I want lightning protection risk assessments done. However, as part of this, will they turn around and say, we're going to do the rolling sphere, we're going to model this building? Or are they going to turn around and say, well, that's an extra? Do you know, can you try to get where I'm coming from? If I'm an end user of a building and I don't have a form of electrical knowledge, how do I know what is a competent and thorough risk assessment to provide the right level of protection and cost?
So that you wouldn't do a rolling sphere assessment at risk assessment level, but you would take a view on how exposed that structure was. And if that structure is completely isolated, then there's a multiplication factor of 1. So you're not changing the sum, are you? If you multiply by 1, you're neither making it more risky or less risky. There is also a multiplication factor of 2 if that structure is completely isolated and also at the top of a hill. And then we have 2 others that go down in factors. So there's one where there are some additional structures around that would provide protection, i.e. they would stop the rolling sphere, potentially, whatever size that may be, touching it. So if you've got a building, as I say, that is adjoined to another structure, that elevation can never see any lightning energy, so that would start to become applicable, and the multiplication factor there is 0.5, so you're halving your risk. And then we have another one where it's surrounded by lots of buildings and they are taller than the structure to be assessed. And you would get that certainly in London, where you could have a building that was in the middle of 3 others. There was one on the rear elevation and one on either side elevation. That's 3 elevations that can never see lightning energy because the rolling sphere can never touch it. And if those structures are taller, the rolling sphere couldn't fit in between. So you would then apply that multiplication factor.
If you don't mind me saying, so one of the more interesting areas where Fenchurch Street is at the terminus, if you walk literally outside, you will come to the new, what do they call it, the square mile, where we're getting all these super scrapers. So you've got the Gherkin there, obviously, and you've got that microphone shaped building and all the rest of it, but there's more stuff going up. There's constantly more buildings. They are demolishing these old, beautiful old buildings and putting these super scrapers of weird, ornate shapes up to become this financial square mile.
Yeah,
that must be an interesting. How does each developer look at the rolling sphere of influence there? Because they're all different shaped buildings, all different heights. They are that area.
you would simply in your risk assessment look at that if your building was significantly lower, if you're sitting next to the shard at 80 odd floors, wherever it is, and you're only at 20 floors, it's significantly taller than you. And if there's another building across the road that's 35 floors, you've got two that are significantly taller than you. So you'd apply that weighting factor. All it would mean is that you need less lightning protection. It reduces your risk, and then you apply that rolling sphere. And because your risk is lower, your rolling sphere gets correspondingly larger. So they're kind of linked together in that if you are surrounded by other things, because your risk goes down, your sphere gets bigger, and when your sphere gets bigger, it touches less things anyway. So most lightning protection contractors wouldn't offer that as standard, but there is absolutely no reason why somebody couldn't ask them to, and it's something that can be done. Certainly Dehn offer that service as a specialist consultant. I guess we would do the risk assessment for you, we would do the 3D model for you, and then we would apply the rolling sphere to the structure for you. So we have the capability to do that, and if you really want, we can make you a little MP4 clip so that you can show it to your boss and say, look, here you go, this is our area of protection that's been afforded, and we can prove that with this nice coloured layer.
Cool. And again, all of that would be compromised later on in 2 or 3 years' time if some idiot comes and puts some HVAC plant on top of your roof, going to a certain point that suddenly does come into contact with the sphere. So do these have to be reassessed?
Yeah, absolutely, they would have to be. If you made a major change like that, of course, you should do that. And again, we spoke on the last podcast, didn't we, about renewing your risk assessment on maybe a 5-yearly basis. If you make a massive change to your structure or your site, then of course you should revisit those things. And let's be honest, it's not expensive to get a risk assessment done. Some lightning protection contractors will do it for free. I have to say, personal opinion, I'm not a fan of that, because I think when people get something for free, they don't tend to value it very much. We charge for ours, but we don't charge a lot. It's £280 to have a risk assessment done. It's not expensive, and you're getting an expert looking at it for you, and it's backed by professional indemnity insurance. So, it's £280 that you're spending that is a bit of a no-brainer. So. I think more people should start to engage with that process, that risk assessment process, and put some more thought into it. And as we've said a couple of times already, the sooner you engage the lightning protection contractor, the more helpful he can be, and the more money he can save you. So it's a case of learning from that and trying to make sure that the next time you remember, let's not wait until we've built it and we have to start drilling holes in things and making things difficult for ourselves. Let's engage nice and early, get a couple of air rods up, and we'll be surprised at how little we need in order to achieve the protection we're looking for and have everything certified and signed off in the way we'd like.
So does 6305 actually have a preference between the sphere method, the mesh method, and where roughly in the process is if it's not at the risk assessment part?
So you use the risk assessment to ascertain your level of protection. Once you've ascertained your level of protection,
determines the spheres.
That determines the size of the sphere, exactly. Yeah. So you do your risk assessment first, and then you determine the size of your sphere. But you should always be looking at that project when you're doing your risk assessment, because the CD factor, the isolation factor, it's absolutely driven by how much of this structure would ever see any lightning energy. So you have to consider a sphere of some kind at that stage, albeit you don't know exactly the size, but you take some educated guesses in that. The only thing the standard says is that the rolling sphere is the best method because it's always applicable on any structure for any level of protection at any height. So it recommends using the rolling sphere, but we all know that unless you say absolutely you should only use this method, people will always use an alternative method. And when you've got the mesh method there, which means just tell the client that he needs a 15 by 15 mesh grid over his entire roof, people are going to default to that because it requires absolutely no input whatsoever. And you will get that little drawing, a little A3 drawing, where someone's marked it with a red felt pen and they've drawn it all on and they've put their little earth symbols in the corner and they've sent it to you and they've told you that that's a lightning protection design. That's something that a 6-year-old does as a project.
The flip of that is you say that they can say, oh, you only just need this, but you also just need to send half a dozen blokes up X amount of height for X amount of time.
Yes, and then bond everything. And then need loads of Type 1 SPDs. So you create another problem by doing
it. Costs a lot of money as well.
Absolutely, yeah.
The biggest problem I see with all of this is in the construction industry, you look at the level and the volume of management people, designers, people will always when you walk into a room, let's imagine, Dave, I turn around to you and say, you're now responsible for building the Shard 2, twice the size. And you can't walk away, and you're just going to sit there and go, oh God, and you're going to have so many problems from so many disciplines and so many designs and so many people coming to you. We need to do this. This isn't coordinated, or that discipline is doing this, and we're going to have to change it. You're going to get right towards the end of it, which is always building services, M&E. Lightning protection will be in there somewhere. There'll be a level of interface with cladding and fabrics, and they're always at the point where they just go,
well, I've often been asked when I do 2396s how I would approach things like this design, simple design. I always go back. I remember the old 2360, 2330. In the syllabus, there were drawings of different processes, and there's something called a critical path network drawing. Do you remember that? Which is where we do a drawing of the journey of the installation, where we consider all the other different things. And in the case of lightning protection, this is going to be something that should be right at the beginning.
With all these
critical path network drawing. And
it was kind of like a systems hierarchy, but for electrical installations.
And this can only be done once this has been done. And so it was something that clerks of the works would just lean on.
Yeah,
back when they were
awesome,
when they were awesome,
powerful, and all knowing and all wielding, and
now unfortunately,
Okay, all right. Let's. What's next on the agenda, JW?
Next on the agenda, we've got thickness of materials in view of things like copper tape.
Well, can I just say we should rephrase that to thickness of installers? Well, that's a bit below the belt, but in my experience, sometimes. Anyway, let's move on. No, let's look at thickness of materials. Is there an issue with the thickness of materials we use, Sean?
Yeah, there is. Very big issue for a couple of reasons. So firstly, a lot of lightning protection systems rely on composite cladding panels on the roofs, and also rain screen cladding and cappings and things like that. Now it's acceptable under the standard, but only in certain conditions, and I'm not sure those conditions are being exhaustively investigated. So we have in part 3, we have table 3, and that talks about the minimum thickness of materials that are permitted in a lightning protection system. And there are 2 columns, column A and column B. And column A is the thickness that you have to use if you never, ever, ever want to or have to consider hotspot, ignition, penetration, punctures, molten metal. So that means it's thick enough to be used all the time, and you don't have to worry about anything else, and you don't have to inform the client. Okay, and it will interest people who know anything about lightning protection to know that the minimum thickness is for copper is 5 mil and aluminium is 7 mil, but we use 3 mil thick tape. So there's an issue straight away there. Secondly, there is the column B. And column B has some alternative thicknesses, which are acceptable. They are much, much lower, much, much thinner materials. And it says that these are okay to be used, but you have to not need to worry about hotspots, ignition, puncturing, molten metals, etc. So it'd be completely inappropriate to use these where hotspots or ignition or puncturing might lead to some further issues. So if you had a building that had internal EX zones, for example, you could not use these materials because that would be an issue. Molten metal dripping into an EX zone should be an absolute no-no. Yeah. There will also be other types of material underneath there. Maybe there's some insulation underneath, which potentially molten metal could drip onto and start a fire. Bearing in mind what happened at Grenfell Tower and the fact that that building was overclad and that building had lightning protection installed behind the rain screen cladding, all of those things start to come together that you start to think to yourself, actually, are we doing the right thing here? Because some of those thicknesses are very, very thin. You're talking sort of 0.6 of a millimeter, 0.5 of a mil, 0.7 of a mil. It's okay to use those materials, but you have to know and inform the client so that they can make that educated decision as to whether they're okay with that. And for me, there's an issue because 3 mil tape is technically not thick enough.
So why the hell, forgive my coarse language here, why are we using 3 mil? Because you're absolutely bang on right. I have seen loads of installations using either a bare, sometimes bare, but most of the times now it's
PVC.
like a PVC, and it's color coded sometimes to match in and blend in with whatever. Why are we using 3 mil?
So it basically is a metric version of the old imperial inch by eighth, which is what people used to use. The cross-sectional area requirement within 6305 is that a conductor for lightning purposes must be 50mm CSA. So it doesn't actually give you a 50mm CSA, it's giving you 75mm. So it's too wide, really, as well. So it's not really the ideal material at all. A lot of companies will also offer a solid circular product. And again, without boring you, sounding like I'm so pro-European, in mainland Europe, all lightning protection is circular, above ground. They don't use flat tape above ground. They only use it in the ground. They use solid 8mm. Well, 8mm circular, of course, is always thick enough because it's 8mm thick. Again, part of the problem is architects do not like circular conductor because they like how flat and neat you can dress conductor tape when you're doing a down conductor. 8mm circular sticks out a bit more than flat tape does, so they do not like it. And again, we said in the last podcast, in my career as a contractor, I spent 20 years appeasing architects and basically hiding systems and making them as least visually obtrusive as possible. And I used to have architects writing to me saying this must be a stealthy solution and things like that. Generally speaking, we're compromising on what we do because we are thinking about the aesthetic and not about the function. And sometimes that's okay, but mostly it's not.
But 3mm flat now does not comply with 6305?
It complies because it's got 50mm cross-sectional area. And
but not with table 3.
But it doesn't comply with column A of table 3, correct? It doesn't meet the minimum thickness requirement. If you don't if you need to consider hotspots, burning, puncture, then you shouldn't really be using 3mm conductor tape.
And is that in 62305-3, did you say?
Yeah,
it's part
now, mate. It's on page
it's
24.
table 3.
Sorry, hang on. What? Sorry, you all spoke over each other. What was that? What one was it in?
Table 3.
Yeah.
Page 22 of the document.
Yeah. Which one? Which four parts?
62305-3.
-3. Okay. Right.
Yeah.
Okay.
This stuff just confuses me. It's, okay, so they do that, but this says that.
Yes,
Yeah.
It's very modelled. I'm personally a fan of 8mm. You can straighten it nicely by putting it in a drill and spinning it a little bit like electricians should do with pyro, so you can get it nice and straight. You also have less junction clamps when you use 8mm because it can be bent more easily. In the old days, when lightning conductor fitters did these kind of things, they would do what was known as a radius sweep. So they would actually bend 25x3 round a corner without cutting it and clamping it. So they would basically just work the metal to make it shaped into a bend. People don't tend to do that anymore. They cut and clamp. But the standard says that the system should have as few joints as possible. So if you're cutting and clamping every time you want to change direction, you're putting in junction clamps that don't really need to be there. 8mm conductor also comes on bigger rolls because it weighs less. So you can have a bigger roll. You don't need as many junctions because you can bend it in any plane, and it meets the minimum thickness. It's far and away a superior product to use. But generally speaking, it's dismissed under the grounds of the architects don't like it. Interestingly, though, it is part of the specification for National Trust and English Heritage. They will only have 8mm down conductors. They will not entertain flat conductor tape. They want 8mm. So their spec says it must be.
What's the Atlas hat say with this?
That as long as it meets the standard, which flat tape kind of does, and as long as it meets the material standard, which flat tape definitely does, then it's okay. That is the Atlas take on it. The Dehn take, in my personal opinion, are slightly different to that. I have reservations and issues with flat conductor tape. I find it very hard if you're going to use that table of minimum thicknesses to explain to a contractor we can't use your 0.7mm thick cladding system on the roof as the conductor because it's not thick enough, and they say, okay, what are you going to put on instead? We're going to put on a mesh of 3mm thick tape. Well, that's not thick enough either. So why are you replacing my existing material with something else which still isn't quite thick enough? So yeah, I have reservations about that, and I think it's something that the standards committee for 6305, GL 61, I think it's something that they need to look at. So I think it's something that needs to be addressed.
This table 3, I need to I need to read more on this. So this is a recommendation table for compliance, or it's a guidance table. It's not a compulsory table for 62305 to comply with.
It's compulsory But because there are the two columns, quite often what people are doing is they're using the thickness based in column B.
I can see why, because they're considerably smaller.
They're much smaller, aren't they? Yeah, significantly smaller. What's interesting as well, of course, is which we haven't even spoken yet, is that a lot of materials that get used in roofing have no thickness value in column A. So lead, which gets used quite a lot, and zinc, which gets used quite a lot, there is no thickness that you can have that is acceptable if you have an issue with hot spots, puncturing, penetrations, etc.
That's the key. That's why they are smaller, because there's no need to be considering the risks of hot spots, puncture, ignition problems on those conductors.
Yeah, absolutely. And as soon as you need to consider those, then you have to do something about it. But I think if you were to talk, and Paul's the asset manager here, if you were to ask the end user and say, are you happy knowing that when 100 kA of lightning energy strikes this roof, you'll get a hole about the size of a 2p piece and lots of molten metal falling in? I think most end users would say, no, I'm not overly happy with that. Thank you very much.
Because the reputational damage, the impact of business continuity from that sort of incident alone, you imagine that happened on a railway station, and that happened on a platform, you'd be closing those platforms, you'd be disrupting timetables. It would run to hundreds of thousands of pounds in disruption before you could,
Oh, in actual fact, a bit of 8mm and a couple of air rods, you'd be sorted.
Yeah, I mean, in terms of molten metal dripping down, I mean, I don't think there's any circumstances where that would be sort of acceptable at all, is there, really?
I have to say, John, I share that as well. I can't think of a scenario where I would find that acceptable. I can't think of a scenario where, that's fine, a bit of molten metal. Who doesn't like that between friends? So, I can't think of a scenario where that would happen. So.
Right. We're kind of going on as these debates seem to keep. This is fascinating stuff. I mean, I don't know about you guys, but this is proper. And it just shows we've got so much to learn. I think if it's okay with you, Sean, if we can come back and get into the big issue of the day, the lightning protection risk assessment, and let's do a bit of depth on that. So if it's all right with you chaps, unless you've got any final thoughts or questions on this, I'll bring this to a close.
No. I just like to say that this is all new information for me, and I'm finding this very interesting.
Yeah.
I really can. The discussion on the spheres, I've always looked at them. I've tried to understand them, but when you mentioned about them being for different categories of protection, that's unlocked a lot of comment. It's made a huge eureka moment for me with the stuff that I've got in front of me. So appreciate that, and I've got great.
There's a lot of follow up on this to do.
There is
anyway. JW, any thoughts?
Yeah, I think we've probably covered enough. I think the thing with the spheres is just how big they actually are, because they're bigger than the building by several orders of magnitude in many cases. I mean, you've got this sort of, even the smallest one is a 20-meter radius. So put that on the ground, it's 40 meters high. That's like a 10+ story building height. So they're absolutely huge. And then, of course, that's the smallest one, and the bigger ones obviously are even bigger. So they're not like you said earlier, they're not tennis balls. They're huge. So
No, they are. Right. Okay. Thank you, JW. Sean, thank you very much. My brain is melted. Part of me is over the moon. Part of me is deeply disturbed and worried. And there's lots of questions I have when I go back to the day job, but it's all good stuff. Remember, folks, the Dehn Red Book, the link will be down below in the comments, and Sean's contacts will be available. He won't be very hard to find. He's on social media. And so Sean, thank you very much. We'll reconvene and talk about lightning protection risk assessments. So for those listening, if you like what you're hearing, please like, subscribe, leave comments, feedback. It's all welcome. It's all good. And until the next one, thank you very much for listening, and take care of yourself and each other. Bye-bye.
Bye-bye.